This is the equation we have. So we're gonna start by like counting the atoms on each side. So oxygen has 8, and since there are 2 oxygens, we wrote it separately so it's easier to balance. 2 and 4 for the second one. And we're gonna do the same on this side. Again, we wrote it separately so it's easier to balance. So we're going to start by balancing the first ones, which is CA. So to balance them, you try to make the numbers the same. So we could do this, and then times 3, because 1 times 3 is 3. And then to make this 3, we put it in this blank. So when we put 3 in this blank, that automatically affects the S and the oxygen. So we have to change those. This is a 12. And so the CAs are balanced. Now we can balance the P. So multiply this by 2. It's the same thing. When we put a 2 here and multiply it by the hydrogen, it affects the whole group. So that would make, this is 6, and then this would make an 8. So the CAs are balanced, the P is balanced, the oxygen is balanced. Now we need to balance the last 3. So to make 2 equal to 6, we can multiply by 3. And it's the same thing, it affects the whole group. So hydrogen, S and O. And now all the numbers are equal to each other and the equation's balanced.
So for our chemical equation, we believe that a double replacement reaction took place, and this is because we could essentially see that the compounds were all switched and mixed up on the product side, which are different from how they were organized on the reactant side. So we could label each of the compounds on the reactant side and see how they changed while looking at the product. So we just simply labeled each of the compounds as A, B, C, and D. And on the product side, we could see that the hydrogen and the phosphate were all like mixed up in the pattern of CB plus AD. And so